Question number 13, that's from gravitation, and it's from the topic that how do you relate potential and intensity. The intensity is given here as a function of x. We need to calculate V as a function of x, and more precisely the magnitude of that. The reference is given, it's at infinity. So one way of doing is that from the answer you go into the reverse calculation by negative gradient, or other way is from the intensity, with suitable integration pattern you can find that, and that's how it goes. Vx minus of V infinity, that's going to be, we require the magnitude, so what I'll do is that integral I dx from infinity to x. Now there's no any difficulty because this integration must not be a new thing to you, because this is how it goes: infinity x and a x divided by x square plus of a square 3 by 2 dx. You can do it by substitution. Of course, the modulus sign is there. You do that, you will land up with option number 3. Okay, now let's go to the next one. Question number 14. Question number 14 is given a certain columns here, 2 columns, and we need to talk about the value of gamma, the Cp by Cv ratio, and the molecule type are mono, di. Now you could say there are 2 diatomic, rigid, non-rigid. So in case of non-rigid, we need to consider the vibrational mode of freedom as well. So what is the expression of gamma? 1 plus 2 by f. If I start with monoatomic, degree of freedom is 3, so that's going to be 5 by 3. Diatomic, rigid, the degree of freedom is 5, so that's going to be 7 by 5. Non-rigid, additional 2, degree of freedom, that leads to 7, so this is going to be 9 by 7. And triatomic, rigid, no vibration, degree of freedom 6, so that will be 1 plus 1 by 3, that's 4 by 3. So here we need to see 5 by 3, and 7 by 5, 9 by 7, 4 by 3. If I see the match, that is going with option number 3 here. That's the correct match there. The option number A goes with 4, B goes with 1, C goes with 2, and D goes with 3. That's how we come to the conclusion. Let's see the 15th. The 15th question, little bit of mechanics, little bit of de Broglie condition. Now what does it say? There is a particle A of mass m by 2. It's moving along x-axis with velocity v0, and it collides elastically with another particle B at rest, and B has this much of mass. Now after that, both the particles moves along x-axis to indicate it's a collision in one dimension, the head-on collision. We need to compute the change in de Broglie wavelength of particle A. Okay, in terms of the initial wavelength lambda naught. So essentially what we need to do is that we need to calculate the value of final velocity of particle A. And since the collision is elastic, so V1 is going to be m1 minus m2 u1 by m1 plus m2. There is also an additional thing, that's 2m2u2 by m1 plus m2. For those who have memorized, they would be in an advantage. For those who haven't, conserve the momentum and the kinetic energy. Now let's see, m1 is m by 2, I suppose. Yes, m by 2 and m by 3. So this is going to be m by 2 minus of m by 3 divided by m by 2 plus of m by 3, and the initial velocity, that's v0. Let's see how is it represented. Okay, that's fine. Now how much will this value be? This is going to be v0 by 5. Now we are all done. The wavelength de Broglie, is h by mv. So because the velocity has gone 1/5, the wavelength will become 5 times, and the change in the wavelength will be 5 minus 1 lambda, that's going to be 4 lambda naught. Option number 2. Let's proceed.